Hello everyone. In this video, we are going to understand about the Gauss-Jordan method. So we will understand the concept of Gauss-Jordan method using an example, and after solving that question using this method, we will see that how we can implement this method using a C program. So let's start. So this method is actually used to find the solutions of group of linear equation, or you can say to find the solution of simultaneous linear equation, we use Gauss-Jordan method. And I hope you know what are linear equations. So just to recall, linear equations are the equations which when drawn graphically, they form a straight line. For example, if I draw this function f of x, so this fx is representing a linear equation. While on the other side, if I draw another graph, let's say this graph, so this function is representing a non-linear equation because it is not a straight line, it is a curved graph. Or we can say the equations something like x plus y equal to 5 is an example of a linear equation because the power of each of the variable in this equation is 1. Whereas this equation is example of a non-linear equation because the degree of the term x square is actually 2. So if there is any term whose degree is greater than 1, that is 2, 3 or something, then that whole equation will be a non-linear equation. Now this Gauss-Jordan method is actually a modified version of the Gauss elimination method. So I have already discussed Gauss elimination method in one of my previous video. So if you have not seen my video on the Gauss elimination method, you can find the link of that video in the description below or in the I button also. So I would recommend that you watch the video of the Gauss elimination method, because this Gauss-Jordan method is actually based on this Gauss elimination method only. So we will see that in case of Gauss-Jordan method, there is just a slight difference or minor difference with respect to Gauss elimination method. And we will see that in case of C program also, there will be just minor difference in Gauss-Jordan method with respect to the code of Gauss elimination method. So before moving to the Gauss-Jordan method, let's see what are the different methods available to find the solutions of the simultaneous linear equations. So we have two categories of methods, direct methods and indirect methods. And direct methods are also known as exact method, and in the similar way, indirect methods are known as iterative methods. So indirect methods, these are the examples that I have already told you in the Gauss elimination method also. So Gauss elimination method we have discussed already. In this video, we will discuss Gauss-Jordan method. And these three are examples of the indirect methods. So now let's understand the Gauss-Jordan method using a working example. So these are the linear equations and we have to find the solutions of these group of linear equations. So just to recall, what are the steps in the Gauss elimination method to find the solutions of these simultaneous linear equations? So in Gauss elimination method, we first converted our given set of equations into a augmented matrix. So we can write A, this slash, and then B. Or we can just write A colon B, anything that you want to write. Now, these are the part of matrix A and these elements are the part of matrix B or the vector B. So these all are the coefficients of the XYZ. So here we can see, here the coefficient is 1, 1 and 1. So we have written the same thing. And then this 9 is written here. The same way we have the coefficient as 2, minus 3, 4. The same thing we have written in the row 2, and 3, 4, 5 we have written in the third row. And these 9, 13, 14 we have written here. So this complete is the augmented matrix. Now what is the next step? So next step was we have to convert this augmented matrix into the upper triangular matrix. And how we convert this augmented matrix into the upper triangular matrix? By applying various row transformation operations. So this will be the form of the upper triangular matrix that we will get after converting this augmented matrix into the upper triangular matrix. So in upper triangular matrix, all the element below this principal diagonal, that is these element, they have to be 0, right? And all these elements, they can be anything. So I have written a general form like A, B, C, D and so on. Now after getting this upper triangular matrix, what are the next step? As we have to find the value of x, y, z, so we will use this upper triangular matrix and then we can find the x, y and z using the back substitution method. So this way Gauss elimination method was applied. Now in case of Gauss-Jordan, what are the steps? So again, first we have to convert the given set of equations into the augmented matrix. So this step will be the similar, that is here we will get the augmented matrix. Then after that we have to convert our augmented matrix into a diagonal matrix. And when we say that we have to convert this matrix into the diagonal matrix. What do I mean? I mean that actually we have to convert only the matrix A part, that is these elements, into the diagonal matrix form. As we have changed only this A part into the upper triangular matrix, the same way we have to convert only this A part into the diagonal matrix. So what is diagonal matrix? So all the element below this diagonal element are 0. The same way all the element above this diagonal element, that is these element, they also are 0. So that type of matrix in which all the element below and above the diagonal element are 0, that matrix is actually a diagonal matrix. So in Gauss elimination method, we just converted the element below the diagonal element to the 0. But in Gauss-Jordan, we also converted the upper element above the diagonal element to 0 also. Now after that, we can find the value of x, y, z very easily. And in case of Gauss-Jordan method, we can just say that x will be g by a, y will be h upon b, and z will be this I upon c. So we will see that how we can deduce this thing from this diagonal matrix. So I think you have understood the difference between the approaches of both these methods, that how they are working. So now let's apply the Gauss-Jordan method on our this question. And here I want to tell you that whether you apply the Gauss elimination method or the Gauss-Jordan method on these equations, you will get the same result. That is, you will get the same value of x, y, z by the both methods. So these are the simple steps that we have just discussed. We have to convert a given set of equations into the augmented matrix. Then we have to convert the A part, that is the matrix A, from this augmented matrix into diagonal matrix by applying the various row transformation. And lastly, we have to find the value of the unknowns, that is x, y, z in this case. So now let's apply all these steps on this given set of equations. So these are our equations. So now let's convert these equations into the augmented matrix. So this is our augmented matrix. So here I'm not putting this slash again and again. So here what we have to do is that we have to make these elements 2, 3 and 4 as zeros, and we also want to make 1, 1 and 4 these elements as 0. So only these diagonal element should not be made 0. All the rest element of this A matrix should be made 0. So now we have to convert this matrix into the diagonal matrix, and we will apply the various row transformation operations to get diagonal matrix. And how I will do that process? So here you can see that I have to make 2 and 3 as 0. So in Gauss elimination method, we have seen that to make these 2 and 3 as 0, we have to take the help of this one. Why this one? Because 2 and 3 will be changed to 0, but this one has not to be changed in 0. So the element which is not getting changed in the particular column, that will help rest of the element in getting them 0. So in the same way, in case of this column, which element is not getting changed to 0? This -3. So 1 and 4 will take the help of this -3 to get converted to 0. So you can say this is row 1, this is row 2, and this is row 3. The same way in this column, 1 and 4 will take the help of this 5, that is row number 3, to get converted into 0. So the method that I will show you here to convert this matrix into the diagonal matrix, in that method I will first convert this 2 into 0. Then on the second step I will convert this 3 to 0. Then I will convert this. Then I will convert this 4 into 0. Then in the next step I will convert this, and I will convert finally this 4 into 0. So let's start our process. So first we have to make this 2 as 0 using the row 1. So what transformation I should apply here to convert this 2 into 0? So I can write R2 equal to R2 minus R1. So this R2 means R2 row is getting changed. So now if you just do this R2 minus R1, that means you will subtract 2 minus 1. You will get 1. You will not get 0. So what I should subtract from this 2 to get 0? So what I can do is, as we have seen in the Gauss elimination method, we can take the ratio. That means I will write R2 minus 2 upon 1 multiply of R1. So this is the 2 in the numerator, and this 1 is in the denominator here. And this is same as R2 minus twice of R1. So if I apply this transformation, what will be the new matrix that I will get? So this is the matrix that I will get. Row 1 and row 3 will remain unchanged, and row 3 will be like this. So each element of the row 2 and the row 1 will be applied with this row transformation, and I will get these computations. That means 2 minus this twice of this minus 3 minus of this. So same thing I have written here for all the 4 elements in that particular row. So after solving this, I will get, so now this element has been changed to 0. So now what is the next motive? My next motive is I have to convert this element to 0. That means I will convert this element to 0. That means I have to change row number 3. So what transformation I should apply? So I can apply R3 equal to R3 minus. Now here something has to be subtracted from this 3 from this row 1 so that I get 0 here. So if I write R3 minus thrice of R1, that means 3 minus thrice of this one, I will get 0 here. So this will be the valid row transformation. So here this 3 is the same 3, and you can write 1 also in the denominator, that is this one. So now after applying this transformation, as we have applied this transformation here, so what I will get? So I will get this matrix. So my row 1 and row 2 will remain unchanged. Only row 3 will be changed. So my row 3 has become 0, 1, 2, 13. So this was actually 3 minus thrice of 1. That means this 3 and this 1. The same way 4 and 1 can be written as like 4 minus thrice of this 1. So 4 minus 3 will be 1. The same way the other element can be computed. So now both these elements are 0. Now I have moved this way. Now I will go to this element and I will make it 0. That means my row 1 should be made 0. That means this element of row number 1 should be made 0. So I should apply the transformation on this row. So what should I write here? So I can write R1 equal to R1 minus. Now I have to take the help of this row number 2. So I have to write some ratio here so that this can change this 1 to 0. So I can write 1 upon minus 5 as the ratio. So if I apply this computation or this row transformation, what will be the final matrix that I will get here? So my row 1 will be so my only row 1 will get changed, and row 2 and row 3 will not get changed. So I will get this matrix. So my row 1 has got changed. So you can see here this element has become 0. So what I did actually, so I used 1 and 0 and I applied this transformation. So how we can do that? So 1 minus 1 upon minus 5 into this 0. So this will be actually 1. So I have written the same thing. The same way you can use 1 and minus 5 and you can put in this row transformation. The same way you can put 1 and 2 in this row transformation, and so on. Now our next motive is we have to convert this element to 0 using this minus 5. So what row transformation I should write? So as I have to change R3, so I wrote R3 equal to R3 minus. So I can write 1 upon this minus 5. So after applying this row transformation, my row 1 and row 3 will not get changed. Only row number 3 will get changed. So I will directly write the answer and you can compute by yourself also. So I will get this matrix after this transformation. So my row number 3 has got changed and this element has become 0. Now here there was some mistake. Here it should be 1.4 and here also it should be 1.4. So now my next motive is I have to make this 1.4 as 0 using this row number 3. And here this row number 3 has also this 2.4, not 24. So now what row transformation I should apply? So I will say row 1 equal to row 1 minus of row 3. But what factor I should write here? So I will write 1.4 divided by 2.4 of R3. So this is like source and this is like destination. So destination will be written in the denominator and source will be written in 1.4. So my row 1 will get changed and I will get here 1, 0, 0, 1. You can compute by yourself by applying this row transformation. So I have got this 0, this, and this. And now I have to make this 2.4 as 0 using this 2. So now I have to make this 2 as 0 also using this row number 3. So this will be my last row transformation and I will write row 2 equal to row 2 minus 2 of, that is this 2 of 2.4 into row number 3. And finally, I will get a new matrix after applying this row transformation. So I will get this matrix by applying this row transformation. So for example, if I compute this minus 15, so I will make use of 5 and minus 12. So if I put here 5 minus 2 upon 2.4 into, I can write 12 here. So if I solve this thing, I will get minus 15. So this is my diagonal matrix because all the element below and above these principal diagonal are 0. So all these 3 elements are 0 and all these 3 elements are also 0. And again, we are talking just about the matrix A part. So here I want to tell you one important thing. The row transformations that I have used to convert this matrix into this diagonal matrix, you may not use those row transformation while you are solving this question. You may use some another row transformation operations. So those row transformation operation will also be correct till the point you are getting these elements as 0. So let's move forward, and now we will find the value of x, y, z using this diagonal matrix. So this is my diagonal matrix. So as we have done in the Gauss elimination method, we have converted this thing into the linear equations again. So if I convert this thing into the linear equation again to find the value of x, y, z, how can I do that? So these are the actually coefficients. These 1, minus 5 and 2.4, and this 1, minus 15, 12, these are the constant value. So I can write this x plus this is 0, this is 0, this should be 0, y plus 0z equal to 1. So this simply can be written as x equal to 1. The same way, I can write this thing as minus 5 and this is 0. So I am not writing the x coefficient. So this will be the coefficient of y. So I will say minus 5y equal to, and this is constant value, minus 15. The same way, I can write this thing at 2.4 and this is the coefficient of z equal to 12. So here we can see now, we found the value of x. Here from this equation we can find the value of y, that is 3, and from here we can find the value of this z. So this z will be 5. So I got x equal to 1, y equal to 3 and z equal to 5 as the solutions of this simultaneous linear equation. So in the Gauss elimination method, we were applying the back substitution method to find the value of x, y, z, but here this method is more simpler than the Gauss elimination method. Here we need not to apply that back substitution method. We can directly find the value of x, y, z in the lesser computation. How? So here what I actually have done, I can say x equal to this constant upon this element, that is 1 upon 1. The same thing was done here also. So this will be 1. The same thing I can do with y. Y can be written as minus 15 upon minus 5. Minus 15 upon minus 5. So this will be 3. And same way, z can be written as this last constant upon 2.4. This will again be 5. So I think by this example, you have now understood and you are now confident that how we can apply the Gauss-Jordan method to find the solution of the simultaneous linear equations. So now it's time to understand that how we can implement this Gauss-Jordan method into the coding part. That is, we have to implement this method into the C programming. And for that, let's first understand the pseudocode for this method. So here is our pseudocode. So first we have to understand what will be the input and output for our program. So for input, we have to ask the user the number of unknown value. For example, for our case, let's say n equal to 3. That means we have to find the value of, let's say, x, y, and z. And now next is we have to ask the user the augmented matrix. That is, we will ask the user to enter the equations. And now equations can be entered in the form of augmented matrix. So here the size of this augmented matrix A is n cross n plus 1. So this is same as we discussed in the Gauss elimination method. As you can see here we have the unknown value equal to 3. That means we have n equal to 3. So we have 3 rows. That means rows are 3. And what is the number of column? So number of columns are 4 because there will be like 1, 2, 3. 3 columns and plus 1 additional column. So it is like the size will be n cross n plus 1. Now after taking the augmented matrix and the value of the n, we will output the value of the unknowns. That is, we have to output the value of x, y, z. And if let's say n equal to 4, then we have the 4 unknown values. Now this is the code to convert our given matrix into the diagonal matrix. Now if we compare this code with the Gauss elimination method code, then in that code we were converting our given matrix into the upper triangular matrix, and there we have used a condition, that is if j is greater than I, in place of this condition if I not equal to j. So this code will actually convert this augmented matrix into the diagonal matrix, or you can say the matrix A in this augmented matrix will be converted into the diagonal matrix. So here I have written the augmented matrix A. Now here I have also written the indexes of each of the element, that is 0, 0, 0, 1 and so on. And after that we applied the various row transformation and converted the elements into 0. So here we converted this, then we applied this, and we converted this element, and so on. At last we find the diagonal matrix. So here we have taken the two loops. Now if we see this A matrix, we do not want to change this -3 and -5. That is, we do not want to change the diagonal elements, but rest of the element of this part should be changed to 0. So that means wherever these indexes are equal, like 0, 0, 1, 1, 2, 2, those elements should not be changed. That means on these elements, row transformation should not be applied. So this condition is saying the same thing. That is, if I is not equal to j. And where are the places where I is not equal to j? Leaving all these diagonal elements, all the other places are satisfying this condition. That is, here 1 is not equal to 0, 2 is not equal to 0. So for these places, we will come inside this if body and we will find the ratio, and then we will take this ratio and we will apply this statement. Now as you have seen in the Gauss elimination method, this line is actually applying the row transformations or the row operations. So this k loop is running how many times? So for n equal to 3, this will be like less than 4. So this will run for 4 times actually. And the number of element in each of the row is also 4. So if we run this code, so let's say I is 0 and j is 0 for the first time. So in that case, I is not equal to j, it will be false because I and j are same. So we will not come inside this if. Then next time j will be 1. So here I is not equal to j is true. So we will come inside. And here we will find the ratio. So see what I have told you in the beginning of this video, that we will traverse in this way. That means first we will make this 2 0, then 3 0. So now we will make this 2 as 0. And now for that we have applied this row transformation. So here you can see we have found the ratio as 2 by 1, or you can say 2. And then we applied this row transformation on which row? Row number 2. That means this row. So here if you see, here I should get the ratio as 2. So that means we should get 2 upon 1. And how I can get 2 upon 1? That means this element which is present at index 1 0 should be divided by the element present at index 0 0. So here if you see, j is 1 and I is 0, and here it is 0 0. So a10 divided by a of 0 0. So it is actually 2 upon 1. So here we will get the ratio as 2, which means we are getting this ratio. Now this ratio will be taken here and this k loop will run 4 times. So here what indexes I actually want? I actually wants to change this row. That means I want indexes 1 0, 1 1, 1 2 and 1 3 to be changed. So here if you see, j is 1 and k is starting from 0. So 1 0, 1 1, 1 2 and 1 3. These indexes will be generated. So all these elements are getting changed. So here if you see, this is, you can say, row number 2. Again, this is also signifying element of row number 2. This is my ratio. And what is this? So this will be signifying this element of row 1. So what is the corresponding element of row 1 corresponding to 1 0? It is 0 0. And for 1 1, it is 0 1. So for 1 0, here what I will get? A of I is 0 and k in this loop is 0. So here I will get 0 0. So for 1 0, I am getting 0 0. Okay. So that means here it will be a10 minus 2 multiply this element. So a10 is 2 minus 2 multiply a00 is 1. So this will be 0. That means one of 0 element will be changed to 0. That means this element. For this, it will be A11 minus ratio will be 2 in 2. Now, for this, K will be 1 as we can see here. So, A of I is 0 and K is 1. That means we are asking about this element and this element. So, here A11 is minus 3 and A01 is 1. So here I will get minus 5. That's why I am getting minus 5. So this K loop is running for this row. That means for each row, K loop will be helping us to traverse each of the row element. Now similarly, when this K loop will be over, then we will again increase this J and J will be 2. So now my indexes are 0 and 2. So actually 0 and 2 is this. But we want actually now this number should be changed. That means we want here 0. That means here it is 0 2, but here I want 2 0. That means indexes should be reversed. That's why I am coming here. That is 0 and 2 are not equal. We are saying this is okay. And when we come here, so it will be A of, that is J is 2 and I is 0 divided by I is 0 now also. So it will be A20. What is the value of A20? This 3, and A00 is this. That means we got the ratio as 3. So this is the same thing. Now we will take this ratio and we will apply this ratio again on the row. So this K loop will run from K equal to 0 to 3, and this particular row number 3, this row number 3 will be changed. So these indexes will be 2 0, 2 1, 2 2, 2 3. All these indexes should be changed using this statement. So if you run this loop, then you will see that all these elements of this row number 3 will be changed to these elements 0, 1, 2 and 5. So in this similar manner, we will run these loops and we will get the diagonal matrix. So for only the diagonal element, this if condition will be false, and for rest of the element, this if condition will be true, and row transformation by these statements will be executed. So I hope you have understood that how we have converted our matrix into the diagonal matrix. So now what is my next task? When I have got this diagonal matrix via this code, now next task is we have to find the value of our unknowns, that is x, y and z. So for finding the value of unknowns, if you see here, when we solve this question, then we see that whenever we are finding the value of x, we are actually dividing this corner element with this element. For finding the value of y, we are dividing this corner minus 15 with this element, and so on for the z. So actually, if I ask you what is the index of this element and what is the index of this element, so here my n is 3. That means my unknown values are 3. So for n equal to 3, this index will be 0, 3 and this will be 0, 0. Now this index will be 1, 3 and this index will be 1, 1. The same way, this will be 2, 3 and this will be 2, 2. And if we give the row number using I, then I will say I equal to 0 is the 0th row, this is the first row and this is the third row. So if you generalize these indexes using I and n, so index will be I, n. So here I is 0 and n equal to 3. And for this I is 1 and this is actually n. In the similar manner, what are these indexes? So these are I, I. Again, here I is 1, here I is 1. So for I equal to 1, these will be like I, I. So in simple sense, we can say that whenever we are finding the value of x, let's say this is xi. So what I mean to say, I will say x1, x2 and x3 are my unknowns value. So if I generalize this thing, what I can say the value of unknown will be xi equal to a of I n upon a of I, where I can range from I equal to 0, 1 to n minus 1. Here actually it was I equal to 2. So for I equal to 0, it will be a 0, 3 because I am taking the case of n equal to 3, and it will be a 0, 0. So what is this? This is 1 upon 1. A03 was this thing and A00 was this thing. The same way, if I say x1, that is I equal to 1. So that way it will be A13 upon A11. So this will be minus 15 upon minus 5, as we can see from these elements in the matrix. So this will be 3. And same thing we can apply for x2. I think by this discussion, you are now able to write the code for finding this unknown value. So we can simply run a loop from I equal to 0 to I less than n, and then we can print that what is the value of unknown. So here I have said ain divided by aii. This will be the value of the unknowns, and this is like value of variable 0 is equal to this result, value of variable I equal to 1, this result. So in Gauss elimination method, to find the value of unknown, we have applied the back substitution method. But here we need not to do that thing, because we can simply find the answers using this division. So for n equal to 3, I will get 3 values of the unknowns. Now let's implement this Gauss-Jordan method using the C program using this code that we have just discussed. So here is the C program to implement the Gauss-Jordan method. So if we start from the main function, then we can see inside main function, we have asked the number of unknowns value, and then we have asked the augmented matrix from the user. And we have taken a matrix A of size n cross n plus 1. And where is n declared? So if we see on the top, n is written as the global variable. I will tell you why we have written this as the global variable. Now if we come back to the main function, we have created a new function that is convert to diagonal, and another function is print unknowns. So convert to diagonal function will actually converting the augmented matrix into the diagonal matrix, and print unknown function will be actually printing the value of the unknowns, that is x, y, z in case of n equal to 3. So now if we see the definition of these both functions, so here is our convert to diagonal function. So this function is taking the augmented matrix as the input and the n as the input. Now we have written the same code that we have just discussed. So we have taken the two for loops, then inside if we have said j is not equal to I or I not equal to j, both are the same thing. We have found the ratio and we have run the k loop. Now inside this if condition, we have also printed something else. What is that? We have printed the intermediate forms. So what this intermediate forms is printing? So this is printing the matrix after each row transformation operation. So this intermediate forms we are printing just for the readability, so that after each row transformation we can know which of the row is getting affected and where we are changing the element to 0. So now this convert to diagonal functions is over. Now we come to the print unknown function. So here again this is taking 2 parameter array and the n value. So here again we are applying the for loop and we have written the same thing, ain divided by ai. So here if you see, I have taken this n as the global variable. Why? So that the n value which is stored inside this global variable, that is the number of unknowns value, should be used here as n plus 1. The same way, the same global variable n will be used here as n plus 1. So now let's run this program and see what is the output. So it is asking me to enter the number of unknowns. Say I said 3, and now let's enter the same augmented matrix that we have discussed. So we actually entered the same augmented matrix. Now we are shown the intermediate forms before printing the final output. So we have been printed 6 intermediate forms actually, and after that value of unknowns are shown 1, 3, 5. These are the same answer that we have found after solving our question. So here if you see in the intermediate forms what these are printing. So what they are doing, they are making this 0, then after that we are getting next 0, after that you can see we are getting this 0, then this 0. Okay, now next time this should be changed. So you can see this is getting 0 and next time this is getting 0. So after this we are printing just the value because this is our diagonal matrix. So here you can see we are getting the intermediate form 6 times because we have to make 6 zeros. So by this intermediate form, we can get to know, okay, what are the intermediate forms, so that if any error comes, we can easily find that error. So I think you have now understood that how we can implement our Gauss-Jordan method using a C program. So if you have any query, comment or suggestion, you can put down into the comment box. And if you have any confusion related to this method, then you can write down into the comment box. I will answer them. You can watch my playlist on the numerical analysis. Link of the playlist is given in the description, and you can find in the I button also. You can find my videos on the other topics also, like C programming, lead code solutions, interview questions, and so on. So you can watch them on my channel. So if you are new to my channel, please subscribe my channel and press the bell icon for further notification. And do not forget to like and share this video. See you in the next video. Till then, goodbye.